Hello everyone and welcome to today's webinar on working with publicly available LiDAR. We're excited to share this topic as we often come across clients unaware that their area of interest has LiDAR coverage through publicly available datasets. Working with public LiDAR can be a great tool for a couple reasons. It can be used for preliminary design, supplemental survey data, and if the quality is high and data is current, you'll be even able to use it for detailed design purposes. Now, for a little bit of housekeeping, for those of you here in the live version of the webinar, please ask questions and engage with us through the Q&A section of the GoToWebinar panel. As usual, we'll address all the questions at the end of the webinar. And just for your reference, all question askers' identities remain confidential. For those of you in the future watching this off our YouTube channel, we do monitor questions in the comment section below, so please ask away. And if you like the content, hit that like button and subscribe. It makes us happy. Okay, so we're gonna go over our agenda for today's webinar. We'll start off by introducing several sources of public LiDAR data within North America, discuss some of the download formats available, and we're briefly get into demonstrating how all this works in our software RoadEng. And with that, we'll start off by how to import and selectively thin a LiDAR dataset, how to create a digital terrain model, and briefly run through an example of a rural road project using publicly available data. There's many different sources that's available for free with public LiDAR data, and here's just a few. Okay, so before I pass it officially over to our training manager, Matthew Dickey, just a quick public service announcement for our next webinar that will happen on April 8th. It'll be continuing our focus on working with various data sources in RoadEng. Using satellite DEM data can be a pretty good alternative if LiDAR is not available. And in this webinar, we'll be hosting with AW3D, one of the world's leading providers of satellite DEM data, as well as with one of our clients, Cambria Geosciences, to take a thorough look at preliminary design, costing, as well as feasibility of corridors using satellite data. It should be a really good one to come. And now let's get into the reason you're here today, which is working with publicly available data. And over to you, Matt.
Thanks, Andy. I'll change presenter here. All right. Yeah, thanks for the introduction, Andy, and we'll just jump right into it. So there are a lot of different sources for LiDAR data or DEM data available online, and a lot of it's free and easy to access. So if you're from the States, there's a good chance you've got coverage for your area. A great resource for finding LiDAR data available in your area is the NOAA U.S. Interagency Elevation Inventory dataset. So with this, we can see the areas with coverage. We can zoom in wherever we'd like. We can click where we are, and we can see if we click that, we've got a listing of where that data can be accessed. So in this case, it's on the NOAA website. It's also on the USGS website. You can get the LiDAR report, etc. And then we can scroll down here and it tells us all sorts of different things like vertical accuracy, quality, and the quality standards are described in a NOAA document. Yeah, so U.S. Interagency Elevation Inventory is a great resource. Another resource is Open Topography. So this one, it's got a lot of coverage in the States. There's also some international coverage. And if you're based out of New Zealand, there's a good amount of data available on there for your area. The Arctic, so this isn't LiDAR data, but it's high-res DEM data, and we can see our coverage there. Australia, we've got our coverage here, so a lot of it in the outback isn't covered, but in the southern portion, there's great coverage. And then for our Canadian customers, on a federal level, there isn't a ton of high resolution DEM or LiDAR data available. So here, if we go to the high resolution digital elevation model, we can click here. There's access to the GeoTIFF data, and we can click through. It's an FTP, and we can access a variety of different data sets from the federal government. They cover Canada, but the coverage isn't great. Now, if you don't need high resolution data, so this isn't LiDAR data, there's also the Canadian DEM, which is a really coarse DEM data set, and but it's certainly better than nothing. So in this case, the grid spacing, I think, is 20 or 30 meters typically, whereas with a LiDAR DEM data set, your grid spacing is typically 1 meter. Now, DEM is a derivative of the raw LiDAR data. So the raw LiDAR data is going to be usually LAS or LAZ format. Now, let's skip ahead to, and there's also this Canadian GIS website. So this is just a collection of different sources. I don't think it's all-encompassing by any means for Canadian LiDAR data, but it can give you a good place to start. Now, the data set that I'm going to use today is, first I should mention, it's a made-up project. I just went online and pulled LiDAR tiles for an area I'm interested in. So if you know the area, don't worry. As far as I know, there's no plans to build a road where I'm clicking. It's just a fictional example. So my LiDAR data set comes from Nova Scotia for this one. And for bringing that data in, I'm going to zoom into the area of interest. The tiles I want are in this vicinity here. So a lot of these different data sets, you have the option to choose your base map. So for the NOAA one, I can come on here and I can choose different data sets, including satellite. So if I want to see a satellite image of the area I'm looking at, I'll do that to make it easier to know where I'm at. Now this data set that I'm downloading, for base maps, it doesn't include imagery, but I do know where it is that I want. So I want that tile. So here I've selected all the layers that are available in the area, and I'm going to click that. And I'd go through and I'd select all the other tiles that I want in the area. And I'd click download. They'd come over in this download list, and I'd just download the ones that I'd like. Yeah, so that's how I get it. Now, I'm not going to download all the tiles that I already have downloaded on here, just because for the sake of an appropriate use of our time. So let's just pretend that I've downloaded that. That comes into my download folder as to be expected, and I've switched it over to my project folder. So we've got our LiDAR data. We know where the project is that we want to work with. Now, first we're going to work in terrain. So the terrain module we're going to use to build a surface from the LiDAR data. And then we're going to jump over to the location module and actually design our alignment. So opening a new instance of terrain. And for this example, I was clicking around. I downloaded a bunch of tiles in the area, and I don't need a bunch of tiles in the area. I need about 4. I've also got a shape file that just shows a rough outline of the area that I'm interested in. So in this case, save bringing in all that LiDAR data, making a massive tin that can't get clunky to work with if it's really, really big. I'm going to thin our data down on import. So I'm going to bring the shapefile in, click open, and there's our area of interest. And then I'm going to grab that LAS data. So I've got it in LAS. I originally downloaded in LAZ. I'm using the LAS files in this case just because it imports faster. The LAZ files are compressed, but we work with both. So here we just want the ground points out of the LAS files. So LAS being the raw LiDAR data, it usually includes all of the points when the LiDAR was flown. If you're working with DEM data, so that regular grid data, you won't have an option of choosing which type of points. So it'll be a reflection of whatever was processed to create that DEM. So LAS though, we're going to grab our ground points. We are going to select the area that we bring the LiDAR in for from our area of interest polygon. And outside of that area of interest, I'm going to skip all my points. So I don't care about them, no need to bring them in. Projection, now I know this is coming from UTM zone 20 and we're working in UTM zone 20. And if I wasn't sure of that, I could, in this case, click the identify button and it gives me a bunch of there. Gives me a bunch of information about the layers that I'm looking at. I can cycle through and look at the different layers. So I know it's UTM in this case. Other examples, so if your data is coming from another source, you might have to look through the metadata or a LiDAR report to find that information. And if it's a GeoTIFF, GeoTIFF will usually carry the world file, so it'll know what projection it's coming from. And that would be in a DEM example. So we'll hit OK. And it's going to take a moment to read in the points. And see, there's a question, just while we wait for this to do its thing. There's a question about, is there any publicly available data or LiDAR data for anywhere in Africa? To be honest, I don't know. So there very well could be. Of course, that's a big continent. I suspect there is at least some publicly available LiDAR data throughout Africa, but I don't know what the coverage is like and what that availability is like. Now, in the absence of publicly available LiDAR, as Andy introduced, we're going to cover in our next webinar, working with satellite-derived DEM data, which is interesting. It's a cheaper alternative than acquiring the LiDAR data yourself. And the lead time is fairly short to make those orders. So here we've got our LAS points brought in. Now I'm going to click off to the side. They're still in there. We can see we have 1.5 million points. So that's great. But let's turn that into a model. So I'll click terrain modeling, generate. I'm going to generate contours. And this will take a moment to think as well. And another question that we have come in is LAZ recommended file format? Yeah, LAZ is a pretty common LiDAR format. Nice thing about LAZ files over LAS files is they're compressed, so they're smaller for sharing, but they are compressed. So when we import, if I had brought in the LAZ files, in this case, it would have taken about a minute to read those tiles in rather than 20 seconds. And we'll wait a little bit longer. I'll also mention with the LAZ question, if you've used the imported LAZ in the past and you've had issues bringing that in, there is a free converter to take your LAS files from LAZ to LAS, and that's not one of our products. It's offered by Rapid Lasso. But we've also just updated our import library so that the any issues with LAZ should be gone. All right, so there's our contours. Now, next few steps are entirely optional. One, I want to have a little bit more context for where I'm at, so I'm going to use our web map tool to grab imagery for the area. So let's go with that. We'll use the Bing file and we'll download that. So this is just downloading the imagery from the web. And once that's downloaded, in this case, it being a fictional road, it's just going to be a low speed, low volume resource road that I designed, but it really could be anything. It could be a road for a new development. It could be a road for a mine. It could be a road for a forestry project. It could be a road for, yeah, as I said, pretty well anything. So I'm going to just bring in a KMZ so we can see where our goal is of getting to. I'm going to save this folder here. And turn up our quality. So there's that. Now I also want to see where we're going. So when I brought that shapefile in, that's great. Shapefile is a pretty common file type to work with. It could have been another format. Here I'm going to bring in a KMZ just showing where I want to end the road. And we'll make it really obvious to see. And we will use so this ground is fairly flat, but it's large scale, fairly flat. But let's turn that drape image off for now. But there is lots of undulating topography on it. It's humpy bumpy. And one of the big challenges with ground like that, building road, is it can be drainage can be a concern. So I'm going to use one of our tools, which is in our tin operations, create watershed feature. And I want to delineate my watersheds so I can use it to easily see where the ridges are and favor that when I design my road, just so drainage is less, we can spend less time on crossings, cross drains, ditching, etc. And you get a sturdier road. So that's brought in. Now I'm just going to change the hatching for that. And we can see where all the different watersheds are for this data set. So I'm done in terrain. I'm going to hit File, Save As, and I'll save it as Top02. And while that saves, I'm going to open an instance of location. And now I'm going to reference that file we've just created. So I click File, New. And let's grab Top02. And we'll just start with a single point entirely from scratch to design that alignment. So here, I'm going to add in that background image that we've downloaded. And we'll configure our 3D view just so we can see a little bit more of what's going on. And this, since my ground is so flat in this case, I'm going to exaggerate my scale just so it's really obvious what the topography is doing when we look at it. My cross-section geometry in this case, it's already set up for the road I want to design, which is just a low volume resource road, but we could do a more complex road easily. And if the default parameters didn't match what we wanted, we could bring in a different cross-section geometry from our e-library. So now let's design. So I'm going to pull that starting point over to where I think I'd like to start. I'm going to wrap around that nose. And now if I start going straight up the hill, I can see things are getting pretty steep, especially if I keep it on the ridge. Big fills and whatnot. So here I'm not able to ride the ridge as I originally intended, but I can cut across that watershed and ride up this other watershed boundary. I'll keep going along. So everything's being updated in real time. I can design as I go, or I can rough in my horizontal alignment and come back and do my vertical afterwards. That's usually the way I prefer to do it. And yeah, favoring those ridges. And there's our point of termination. And I've got that roughed in. I'm going to add my horizontal curves to start, and I could go through and add an individual curve to each one. In this case, I can see my default curve set to be 100 meter radius, so I'll define that as my default curve and apply it to all empty IPs. And I'm sure there'll be somewhere where it doesn't fit, but we can go through and adjust that afterwards. And let's see here. So that, we're zoomed way out. That's not a horrible cut, but we can do better. Let's pull that around. And I want to tie that in a little smoother with the existing road that's there. Let's pull that back. And we could absolutely go through and design this manually for our vertical as well. And we can jump back and forth between the different views as we wish. Where are we at here? So that is a pretty big fill. Let's see if we can pull that. So I'm looking at my 3D view to identify something that I'm not crazy about, and it's just flat ground. So we could do the manual approach, go through and minimize our cuts and fills, watch our mass haul diagram update in real time as we design. Just for the sake of keeping things fast and showing a cool feature, I'm just gonna optimize my vertical alignment rather than doing it the traditional way. So just a quick shortcut. I won't go into the details on all the settings here. If it's something that interests you, we do have other videos that will talk about all the parameters I'm changing here, and talk about what the software is using to solve the problem. But right now we'll just use it as a a tool to speed things up so we get the optimal alignment without sitting here and watching me click through iteratively. So this is just taking a moment. What's happening is it's sampling all the different locations that vertical alignment could be placed. And then it's going to generate an alignment for us. Once that's done, if it was a real project, I'd go through and pay a little bit more attention to see if there's my vertical's optimal right now, see if there's any room to improve things by moving my horizontal. I may even use our horizontal optimizer for that. And then once I'm happy with my alignment, I'd go through and add in my structures. And it should be solved here shortly. Another nice thing with this optimizer is we can use it to compare different options. So once this is done, we can jump ahead and see how different routes compare that have already clicked in on an alternative data set. Or sorry, same data set, just alternative alignments. And so and it's just calculating now, so it's found this best solution. Now it's generating it. There we can see that. And now I go through and add culverts where I need it. And since we've favored the ridgetops for most of our route, we can see, okay, I'm crossing a watershed here. Well, we could ditch it back to the next one if we wanted. It would be a fairly long distance to do that. So I'll just add a culvert at that location. So there, we've added a culvert, and we could keep going through and add our culverts in all the appropriate locations that we need them. I'm not going to do that just because once you see one, it's largely the same. We have the function to tweak things as you wish, change your length, change your attachment point, skew, gradient, change your structure type. But yeah, our focus more is just working with the LiDAR data sets. This one, we could also create our finished product by using multiplot. So there we are. And as I mentioned, we can compare different options. So with that, let's open up something that's prepared here. Nice thing about LiDAR data, one of the nice things about LiDAR data, there's many, is that you usually get it on a landscape level. So you're not hemmed into the area that's been surveyed. You have lots of flexibility to explore different options. Well, we ran through that example with me talking most of the time in a half an hour. So we did one example, and if it was just me clicking in there and not talking and explaining things, we could have trimmed the time down so we can explore a bunch of different routes in a fairly short period of time. And in this case, it's just calculating all the different alignments that are in this file. And then we can click through and see with our costing side of the software, which the optimizer's using, which route's cheapest. Yeah, so this should be done soon. I'll get to the questions that have come in here momentarily. So yeah, here, this is roughly the alignment that I designed live. So we can see we're at a cost of 156,000. This other alignment, so I've followed different ridges, is coming in at 173. And this longer route is 270, so that's not good. And then this one's down at 220. So we happen to get it right in what we did live. But it's nice to have the peace of mind that we made that decision and we've explored the other options as well. All right, so let's dig into some of these questions. Any thoughts on minimum accuracy for data? So that will depend a lot on the project at hand and how tight you want control when you're constructing it. That's up to the designer to decide, and as mentioned, when we talked about our different sources, a lot of the time you'll be able to find a LiDAR report for those sources, even if it comes from publicly available data, which will give the accuracy limitations in it. Occasionally, even if you have not great accuracy limitations in the overall survey for the data, if you're looking at things in a more local level, a lot of the times those accuracy limitations are an overall bias for the area, so you can improve things by just shifting your data set up or down an appropriate amount. Yeah, but that's ultimately up to the designer to make that call. Another question, is the Watershed feature new? The LiDAR feature, or the Watershed feature is relatively new. It was included in our version 9 release, and yeah, we're working on some other hydrology tools to be released in version 10, which make it just add more flexibility and easier to work with these kind of landscape level data sets. Oh, can we share the LiDAR sources for the example? Yeah, it's a fictional example from public data. I've no problem sharing that. Just send us a link, or sorry, an email with that we can get back to you with the request, and we'll give you an FTP link for that. And then, oh, and we're getting close to time. Let's just wrap up a couple more. What are the costs mentioned that I've mentioned based on? So in this one, I ran the optimizer. Our optimizer's function is to minimize earthworks and earth movement costs. So in this example, we've got our ground types. So in this, I've only assigned one ground type along the length of our road. So it's just the default in this case. We could add different layers for different materials and add ranges to them to account for the actual geological conditions at the site. Those ground types are defined in our ground types table here. So by default, we've got overburden, gravel, hard pan, solid rock, fractured rock. The user can add whatever they want for those. Those ground parameters carry geotechnical information associated with it if you'd like, but they also carry these cost parameters with them. So here, our handling costs are user-defined values. They can change depending on the material they're applied to, so they can be unique for each material if you'd like. And we've said in this case, our default material overburden costs $12 a cubic meter to excavate. So if you were working in Imperial, $12 a cubic yard to excavate, and $4 a cubic yard or cubic meter to placing it back. And again, the user can add that or define that however they'd like. So that's our excavation costs. Our haul costs are defined in here. So our haul costs are shared amongst all materials, but we can define a hauling cost, a loading cost. It's going to figure out your best free haul and all overhaul breakdown. And those costing parameters are used to calculate our total cost over here. So when I'm doing my comparison, that's what I'm looking at. And it's also the costing relationship that the software is using. So, yeah, we're a bit over time. And yeah, Andy, do you have anything you'd like to close with?
Nope, not on my end, but we hope to see everyone next time.
All right. Well, thanks, everyone.